Hey folks, welcome to NASA Launchpad. I'm your host, Justin Tully. I'm sure you're all familiar with Earth's next-door neighbor, Mars. If not, it's the fourth planet from the Sun. It's been hanging around the vicinity for about 4.5 billion years, and it can occasionally be seen in the night sky as a red, hazy light. Humans have been studying Mars for hundreds of years. In 1609, Galileo was the first person to peer through a telescope and get a more intimate image of what many could only have dreamed of, an up-close and personal view of the red planet. As time progressed, so did the capabilities of telescopes. In fact, from the late 1800s to the mid-1900s, many astronomers believed that Mars was home to majestic seas and lush areas of vegetation. Some even believed that intelligent life existed on Mars, just because of what they saw through their telescopes. But hey, that's science. You make educated guesses based on what you know, then change your ideas based on what you learn. Dark markings on Mars's surface were once believed to be caused by vegetation growing and dying. Thanks to new sophisticated equipment and robotic visits to Mars, it turns out they were caused by Martian wind. It wasn't until the 1960s, when NASA's Mariner missions flew by and snapped pictures of Mars, that many of the myths about the red planet were dispelled. That doesn't make it any less interesting, though. There is still the possibility of life having once existed on Mars, or presently existing on Mars. No, not in the form of little green men, but on a microbial level. Now, taking pictures is great and all, but nothing is better than the real thing. So to get a better feel for Mars, scientists and engineers built Phoenix. And this bad boy could do a lot more than anything that's come before it. Phoenix was launched in the wee hours of August 4th, 2007. Beginning its 9-month-long, 681 million kilometer journey to the legendary red planet. Now, landing on a planet isn't as easy as simply dropping a spacecraft onto it, although that would be nice. There's actually a lot of steps to the process. On May 25th, 2008, Phoenix entered Mars's atmosphere. It used its heat shield to slow down the high-speed entry of 5,600 meters per second, or around 12,500 miles per hour. It released a supersonic parachute, then detached from its parachute and used its rocket engines to land safely on the planet's surface. But where? How do NASA scientists decide where a spacecraft should land? Well, this picture shows the area of high water ice content in the polar regions of Mars, and NASA has a motto when it comes to Mars: follow the water. Here on Earth, anywhere you find water, you find the potential for life. So perhaps the same is true of other places outside of Earth. That being said, Phoenix's landing spot was further north and closer to the ice-covered poles than any spacecraft has ever been before. Phoenix had two primary goals. One was to study the history of water in the Martian Arctic, and the other was to search for evidence of a habitable zone and assess the biological potential of the ice-soil boundary. And to do that, the spacecraft was packed full of gizmos and gadgets to perform all sorts of experiments and tests. One of these gizmos was a robotic arm with a shovel attached. How futuristic! It was used to dig up samples of the Martian soil for experiments. So when it did just that, it discovered an odd bright substance that 4 sols later was gone. Oh, a sol, by the way, is a Martian day. It just so happens to be about 37 minutes longer than a day here on Earth. Scientists had a pretty good feeling they knew what the disappearing act was all about. But to be safe, they enlisted the help of Phoenix. A scooped sample was carried by the robotic arm and dropped into the Thermal and Evolved Gas Analyzer, or TIGA. But really, it's just a high-tech oven. The soil is dropped onto a screen, where some of it falls through into one of TIGA's tiny ovens. The oven closes and heats what's inside. The gases that come out of the oven are then analyzed. When this particular sample of the soil was analyzed, water vapor was detected. That means that the bright white substance turned out to be water ice. TIGA also discovered calcium carbonate. This is pretty cool because calcium carbonate is formed in the presence of liquid water. And we all know that liquid water is the basic ingredient for life as we know it. Let me tell you about the Surface Stereo Imager, or SSI, which is really just a fancy name for the camera. The Surface Stereo Imager were Phoenix's eyes, and I mean that almost literally. Engineers built the device with 2 optical lenses that would allow for a 3-dimensional view, just like our eyes. And the SSI sent back some amazing images of the Martian landscape. Interesting fact, The SSI actually captures an image with 3 different filters: a red one, a green one, and a blue one. Once the images are beamed back to Earth, the colors are applied to each photo and then overlaid, getting a color image. It's pretty cool. Now, I could go on and on for days about this spectacular mission. The Phoenix lander started sending data back just 17 minutes after landing and for the 162 days it operated. And scientists have their work cut out for them. Phoenix sent back enough data about Mars to keep them busy for years, at least for the next decade. Being human, though, scientists thirst for more. This is a good thing because that means that the next mission to Mars will be just as exciting. Perhaps it'll find proof that life once existed on the red planet. And one day, humans will be going to Mars. So each mission that we send to the rocky red planet is another step closer to actually stepping foot on its surface. Perhaps you'll be the first person to walk across the Martian landscape. Someone's got to do it. For NASA Launchpad, I'm Justin Tully. Thanks for watching.